So the rate determining step is the slowest step in a rate equation. Are you getting it now? And determines the rate of the reaction. This is the slowest step. So many reactions consist of a series of separate stages. Are you getting it now? Chemical reactions, organic reactions, there are stages that are involved in the process. Now each step has its own rate and the rate constant. So the overall rate of a multi-step process is governed by the slowest step. Do you understand what I'm saying now? That's what determines what? The rate of the reaction. The slower step. Just like the production line, where overall output can be held up by a slow worker. Are you getting it? Let's say in a group, you are put in a group. The weakest person there will determine what the sources of that group. The weakest person there will determine how far the group will go. Are you getting it now? The same thing in a reaction mechanism. That in fact the slowest step determines the rate of the reaction. And that step is known as what? The rate determining what? Step. So if there's more than one step, the rate equation may contain what? All the reactants in its format. So that is the slowest step. The step that determines what? The rate of what? The rate of the reaction. Like I gave examples. I give an example. Are you getting it now? That the student that comes late to class, are you getting it now? Will determine the sources of that class. How far that class will go is determined by that student. So in a multi-step process, in organic reaction, are you getting it now? The slowest step is the rate determining step, and that is what determines what.
It's like saying an RB is the strongest, its weakest number.
Yeah, thank you very much. Are you getting it now? Let's see the reaction between propanol and iodine. Iodine and propanol react in the presence of an acid. Do you understand what I'm saying now? So this is the rate equation. The rate equation is what concentration of propanol on the concentration of what? The acid. You discover that iodine is not there on the rate equation. Are you getting it? That means the rate of reaction doesn't depend on the concentration of what? The iodine. But it depends on the concentration of propanol and also the concentration of what? The catalyst. So why do hydrogen ion appear in the rate equation? Because the rate of reaction is depends on the concentration of the hydrogen ion. So the reaction is catalyzed by the acid. Hydrogen ions affect the rate, but what is unchanged what overall. So iodine do not appear because the rate determining step does not involve iodine. Are you getting it now? So just as I explained, that the slowest step of any multi-step reaction is known as what the rate determining step, and it is the species involved in this step that are found in the overall rate equation. So the slowest step, are you getting it now? Is what is found on what? On the rate equation. Just as example, catalysts appear in the rate equation because they affect the rate, but they do not appear in the stoichiometry equation because they remain chemically unchanged. Are you getting it? By the time we talk about homogeneous catalysis and heterogeneous catalysis, you are going to see the effect of a catalyst on the rate of reaction and how a catalyst remains unchanged at the end of the reaction. Now, hydrolysis of halogenoalkane, if you remember, we did SN1 and SN2. SN, which is substitution nucleophilic in the molecular. That means the rate of reaction depends on the concentration of the halogenoalkane and not on the nucleophile. That's what we call it SN1. Are you getting it now? Then we'll talk about SN2, that the rate of reaction depends on the concentration of the halogenoalkane and the nucleophile. Now, if you look at what we have on the body, you discover that looking at the rate equation, that means the rate of reaction depends on the concentration of the halogenoalkane and also on the nucleophile. Are you getting it now? So what happened? That means this is what? SN2. And this is the slowest step because this is the slowest step that appears on the rate equation. So once you see the rate equation, you already know the slowest step. Are you getting it now? Do you understand what I'm saying now? Every other stage that is coming up has to be fast. Are you getting it now? Because that is the main point. That is the rate determining step. That's what determines the rate of reaction. But with others, it only depends on the concentration of the halogenoalkane, which is SN1. If you look at the rate equation, now you discover that it is only the concentration of the halogenoalkane. That is why if you look at it is second order. First order with respect to halogenoalkane, and second order with respect to the nucleophile. But when you come to this one, this is first order. And that is what appears on the rate equation. So look at the stages that is involved. If you can remember in AS, first the halogenoalkane has to break, that is the carbon halogen bond has to break before the nucleophile comes in. But in SN2, what happened? The halogen immediately the halogen is breaking off from the carbocation. What happened? The nucleophile is coming immediately. So the rate of reaction depends. So if you look at the step, you discover that it is the concentration. Please take note of that. It is the concentration of the halogenoalkane that appears on the nucleophile on the rate equation. Are you getting it now? So what happened? I said that if you look at the slowest step, it is the concentration of the reactant of the slowest step that appears on the rate equation. Does that make sense now? The concentration of what? The concentration of what? The slowest step, the constitution of the reactant of the slowest step that appears on the rate equation. So the first step involves what? Breaking what? Carbon halogen bond. The second step involves what? The two ions joining. So if you look at immediately after the rate determining step, every other step is fast. Do you understand what I'm saying now? So the halogen alkane what comes immediately. So the first step is slower as it involves what? Bond breaking, and energy has to be put in. So the first order mechanism is favored by what? Tertiary halogen alkanes, because the hydroxide ion is what? Hindered in this approach by alkyl groups if the mechanism involves what? The hydroxide ion and what? The halogen alkane what? Colliding. So we'll talk about that. Do you understand what I'm saying now? That for chemical reaction to take place, the reactant particles must what? Collide. The carbon halogen bond have to break, and before it now what? It now comes in. So when we talk about the rate determining step, it is slowest step, and that is what determines what? The rate of what? The rate of the reaction. Now if you look at this, now you discover that if you look at this, look at the stages involved. Are you getting it now? Look at the rate determining step, look at the stages involved. This is the slowest step. So what will be the rate equation? Please, I want you to tell me. The rate equation will be R is equal to what? Please tell me the rate equation for this multi-step process. R is equal to what? K concentration of what?
H2O2.
H2O2.
And
concentration of what? The slowest step. Every other step is fast. So the rate determining step is step 1, as it is what? The slowest step. And from what we've written down, that is what appears on what? On the rate what? On the rate equation. Does that make sense now?
H2O2 would be there, but
does that make sense?
H2. So why is there no 2H2O plus?
2H2O plus.
H3O.
So let's get the overall equation. If you want to get the overall equation, what do you think we'll do? Yes, what do you think we'll do? To get the overall equation, this will cancel out this. Is that? Does that make sense now? Yes.
Wait, just sorry, sir.
Yes.
Why is it H2O2 I minus?
Let's get the overall equation. This will cancel out this. This overall equation is that. Are you there? This overall equation is that.
Yes.
So what do we do now? So the one we cancelled out the one we're supposed to cancel out. So what do you have? You have what? H2O2 plus what? 2H3O. Is that? This and this. Is that? Plus what? 2I minus. To give you what?
I2 plus 4H2.
I2 plus how many? 1, 2, 3, 4. Is that okay? Plus 4. This is the right equation.
So it's the rate equation. Why is it H2O2I minus?
H2.
Why is the concentration
The rate equation you just wrote up there.
Okay, that's the slowest step. The concentration of the rate. Do you understand? The reactant of the slowest step. That's what appears on the rate equation. Do you get that now?
Yes.
I want to emphasize that now again. I say what appears on the rate equation. Please look up. Look up. I say the concentration. That means you've not gotten it for you to be asking this question. I say the concentration. Are you getting it now? The concentration of the reactant of the slowest step. That's what appears on the rate equation. The concentration of the reactant of the slowest step. That's what appears on the rate equation. This is the what? This is the reactant. Are you getting of the slowest step? That's what appears on the rate equation.
Sir,
does that make sense?
another
So
question.
that.
So
Cut
does
it
that
now.